Let me show you a third distance measure. Before we dive into it, let's take a closer look at two customers. Customer 124 and customer 125. Customer 124 spends 40 euros on vegetables and 40 euros on fruit, while customer 125 spends 100 euros on vegetables and 100 euros on fruit. According to both Euclidean and Manhattan distances, these two customers appear quite different because the total amounts they spend on vegetables and fruit are significantly different. However, if we look at the pattern behind these numbers, there's an argument to be made that they are actually very similar. Consider this. Customer 125 might be a parent with 3 children, while customer 124 could be part of a household without kids. The larger amount spent by customer 125 might simply reflect the need to buy more food, but the spending pattern, the ratio between vegetables and fruit, remains the same. If you're more interested in comparing the ratios between variables rather than their absolute values, the cosine distance becomes a better measure. Cosine distance captures the similarity of the spending pattern, regardless of the magnitude of spending. Intuitively, imagine drawing arrows from the origin of a graph to each customer's data point. Customer 124's data point would be represented by a blue arrow, and customer 125's data point would be represented by a green arrow. In this case, both arrows align perfectly because the ratio of spending between vegetables and fruit is identical for both customers. In contrast, if you look at customers 123 and 126, their arrows would not align since their vegetable to fruit spending ratios differ. For customers 124 and 125, the cosine distance formula shown here would calculate a distance of 0. This result reflects that their spending patterns are identical in terms of the ratio between vegetables and fruit, regardless of the total amount spent.